So let me turn it over to science, which is going to be, I feel like it's a Nearpod, but I don't remember. So it is a Nearpod. Okay, wonderful. So you should go into Canvas, go to Nearpod live lesson for Monday. Similar to what we do in school. And if you don't see what I see, let me know when you're in Canvas. So it's Monday, science, testable versus non-testable questions. And let me know by unmuting yourself because I can only see a couple of people at a time. So far, there's 3 people on, 4. I'm gonna give you guys about 2 more minutes to try to get to the Nearpod.
Miss Bird,
Yes.
where do I find it? Where do I find the Nearpod?
In science on Canvas.
Okay.
It's yesterday's Monday, Science Monday 413.
So you already did it.
We already did that.
I just put that there. The science testable versus non-testable, I did that this morning.
Okay.
All right, so Amelia, you have a computer, right?
Yes.
Okay, so just go into Canvas. Logan Flores, are you
Say you're in Canvas.
on your computer?
Miss Bird, we're in Canvas.
Okay, well, you know how to do it, Amelia. We've done this before. Rochelle, were you able to get on? Yes? I can't hear you. Oh, okay, yes. All right. So we're talking about testable and non-testable questions. That's questions that we can either do an investigation on or we cannot do an investigation on. So we want to think about what can we do when we're talking about investigations. When we do investigations in class, are we able to complete an investigation using testable or non-testable questions? So the first thing that you guys should have did yesterday, and my hope is that you guys already completed the question of the day in Canvas. So I'm gonna check now. Now that was yesterday. So looking at that, 15 people did it, good job. So Samuel, Anima, Logan F, Wilfred, Amelia, Keandre, John, Leah, Anahi, Josie, Logan S, Anaya, Diana, Erasmo, and Gabby did it already. So after the question of the day was supposed to be this, and I don't know what my brain was going through, but I forgot to put it on there. So we're just gonna quickly go through it, okay? So the first thing that we were supposed to do was watch this YouTube video about testable versus non-testable questions. So I'm gonna pull it up so that we can watch it together. It's really short, and it's gonna help you with the actual sort, and at the end of the week, there's a assessment. Okay, so one moment. Ms. Rodriguez, let me know if you can hear it once it starts playing, please.
There's all kinds of different scientists out there, working all over the world in all different kinds of environments, researching all different kinds of topics. But they all have one thing in common. They ask questions.
Scientists are naturally curious, right? So it all starts with sort of just a curiosity to know what's happening in something.
But to actually find out what's happening in something, scientists have to ask a very specific type of question called the testable question. To understand why testable questions are at the heart of science, we're going to look at the work that Kim and Kay are doing. Kay Beidel and Kim Tamachakon are marine microbiologists at Rutgers University.
The work that we're doing is looking at the role that light plays in mediating host-virus interactions in the ocean.
Could light be structuring infection in the infection process itself?
Let's back up. Kim and Kay's team studies the interaction between a tiny phytoplankton called Emiliania huxleyi, or EHUX, and the virus that infects EHUX. These guys are phytoplankton, and they use sunlight to make their own food, which means they need light to grow. These guys infect these guys and kill them. When Kim and Kay were on an expedition together, they wondered whether light was affecting the interaction between hosts and virus. They were curious.
And so I was like, well, how does that work?
Kim wondered, how does light affect this host-virus interaction? While this is a great initial curiosity question that often initiates scientific research, it's not a testable question because
It could be a number of different answers. It can affect the virus itself. It can lead to viral decay. It can enhance growth rate of the host, and so therefore it stimulates viral production. How does light do it is not there's too many ways to answer that question.
Okay, this distinction may seem a little subtle, so to help understand what makes a question testable, we'll use the SMART acronym, where SMART stands for specific, measurable, achievable, relevant, and temporal. We're going to go through each one by taking our initial broad question and then modifying it into an actual testable question that Kay and Kim's team tested. So, starting with S, specific. For a question to be testable, it needs to be specific, meaning you should be asking a question that has one defined answer. This is why you can't just say,
How does light affect host-virus interactions? And there are just a million different ways to answer that. There's no defined answer.
and with no defined answer, you can't design an experiment that will give you meaningful results.
But if you say, does light affect host-virus interactions? Then your answer is either yes or it's no.
Now that's specific. Now you can design experiments to test that question.
In order to answer that specific question, we have to design a number of different experiments. It's not one experiment per question.
And that's because light is still very broad. Light can have different intensities and it can have different wavelengths.
We did an experiment where we infected in the dark, and then we did an experiment where we infected in constant light, and then we did an experiment at different light irradiances.
So for our initial question to be testable, we need to think about how to make it specific. So it becomes this. Does light at different wavelengths and intensities affect host-virus interaction? So, specific, check. Next, M, measurable. A testable question should lead to answers that have measurable results. So is the answer to this question measurable? Well, you can measure the amount of light organisms get, you can measure the brightness of the light, you can measure the amount of infected cells versus non-infected cells in a sample. But if you want to measure the effect of light on the viral process of infection, you have to be able to measure what's going on with just the virus. And one of the challenges that Kim faced is that light affects both hosts and viruses.
And so if you test too big of a range of light, now you've got a situation where not enough light and the host is unhappy, and too much light and the host is unhappy.
Kim and Kay's team were able to find a narrow range of light intensities that affect the virus but keep the host happy. So they know the question they are asking is measurable. So we can modify this question accordingly. Does light at different wavelengths and intensities that don't affect the host affect the virus? So measurable, check. Okay, next, A, achievable. Whether you are in a science class or a professional scientist, you need to ask, do I have the stuff to do this thing in the time I have?
We push our students to recognize that there are constraints in terms of what they can do in the classroom with science, with the time and the supplies that we have. But we parallel this to the constraints that a scientist would see in the field. They have more resources available and more time available to them, but they still go through the same process.
So is our question achievable? Well, to answer this, we need stuff like lights that can be adjusted to specific brightnesses, bottles for samples, a big machine called a flow cytometer that can count infected cells, and finally, you need samples of cells.
The organisms we study, we can grow in the lab and we can do controlled experiments, but ultimately we want to know what are they doing out in nature in this big ocean at this small scale in a really big place. And so we want to try and replicate that. So when we're actually going in and designing a testable question for a process that we're trying to measure at sea, can we achieve that condition that's going to actually allow us to answer that question that we're asking?
So if you have the stuff and you have the time, then it's achievable. Check. So the question becomes, does light at different wavelengths and intensities that don't affect the host affect the virus? Given that our equipment and the time we have allows us to perform an experiment on this organism that can be successfully grown in a lab. Next, relevant. Is this question even relevant? For example, our question so far is specific, measurable, and achievable. But what if here we're asking about wavelengths of light that aren't even present in the ocean? Well, obviously, if these guys live in the ocean and there's not a lot of red and yellow light where they are, it's not relevant to ask about those wavelengths of light. So the question becomes, does light at the wavelengths present in the ocean and intensities that don't affect the host affect the virus? Given that our equipment and the time we have allows us to perform an experiment on this organism that can be successfully grown in a lab. Relevant? Check. Finally, temporal. The question should be grounded in time. So back to our question. Does this question relate to a specific time?
The infection process that we study takes place over a certain, few days, 3 to 4 days. So the experiments that we set up are not gonna run out for, weeks at a time. So we may be interested in asking questions within the first 24 hours.
You can't do an experiment that never ends. That's why your testable question has to have a time component to it. Temporal, check. And now finally we have arrived at our big testable question. Does light at the wavelengths present in the ocean and the intensities that don't affect the host affect the virus in the first 24 to 48 hours of infection? Given that our equipment and the time we have allows us to perform. Because professional scientists practice thinking scientifically all the time, they don't need to consciously go through this SMART acronym every time they ask a question, nor do they always arrive at one master question like we've done here. But they are always making sure that the questions they're asking are testable so they can run experiments and get answers that are actually meaningful. If you like the tools of science, please
Alrighty. So going to the video, we've done SMART lessons. I'm sorry, not SMART lessons, SMART questions in class. So we're going to keep that same thought process as we're going through our Nearpod, okay? So everyone that is able to be logged on to Canvas and be in the Nearpod. So when we go back to our Nearpod in Canvas, and remember, it's Monday's Nearpod. They give us it'd be helpful if you guys could see it. They give us an example. And it says, is the question testable? So it says, here is a comparison of untestable and testable questions. So remember our SMART acronym. It has to be specific, which means that it has like either a yes or no answer. It has to be measurable. So I have to have some results that I can measure. It has to be something that we can achieve. Do we have the stuff and the time in order to answer this question? It has to be relevant. Is the question worth asking and figuring out an answer to? And then it has to be temporal. Is there a specific time frame that we're going to use to answer the question? So they give us an example and it says, how do plants grow? Well, that's not specific. It's not giving me a yes or no answer. But then a testable question says, will adding fertilizer make plants grow taller? That is a specific question. And then the next one says that is untestable. What prevents ice from melting? They don't give us a time frame. They don't tell us a specific question that we're trying to answer. But a testable question is, what is the best insulator to keep ice from melting? And then they give us examples as to why the questions are testable. So for this testable question where it says, will adding fertilizer make plants grow taller? What you change is adding fertilizer, and what could happen, the plant might grow taller. We did that yesterday in math when we talked about the tomato plants. One person's tomato plants grew 1 inch each day, and another person's tomato plant grew 1/2 inch each day. And then another testable question says, what is the best insulator to keep ice from melting? What is the thing that we're changing? The insulator materials, and what could happen? The ice could melt slower. So what we're going to do is think about, are these questions testable or non-testable? If you did the sort yesterday, you should have been able to answer the question as far as, are the questions testable or non-testable? So I'm gonna give you a couple of minutes for you to try it. It says, does a fish get angry if you take away food? So why is this not a testable question? It's not testable because we have no way to measure the fish's anger. And how can we make it a testable question? So we're either going to add a specific type of question, we're either going to add a measurement, we're going to add some stuff, we're going to figure out a time frame. So that's what's going to make it a testable question. So it says, do fish lay fewer eggs when they have less food? And the question is better because you can measure how much food the fish eats and how many eggs it lays. So that's a measurable one. That's what's going to make it a testable question. And the next question says, will dogs be affected by the weather? And it's not testable because it's not specific enough. It doesn't tell me what type of dogs. It doesn't tell me what type of weather. It doesn't tell me when. But how can we make it testable? Do dogs shed more hair when the weather is warmer? The question is better because it asks specifically about what happens in warm weather. So now your two examples say, do plants like water? Why is this not a testable question? So if you don't have access to Canvas and you're not able to do it on Canvas, you're gonna send it to me in a private chat. Why is that question not measurable? I'm sorry, not measurable, not testable. And how can you make it a testable question? And it has to specifically be about the same subject. For here, it has to specifically be about plants and water. And then the next one says, will sleep affect the student? You're gonna tell me why the question is not testable here. And then how can I make it specific? How can I make that question specific so that it is testable? So I'm gonna give you about 5 minutes to share with me your answer on Canvas if you have it. And if you don't have it on Canvas, then you can actually send it to me in a private chat. So I've started the timer so you can be working. Good job, Lana. Now make it a testable question. Oh, good job. Good job, Lana. So remember, your goal is to tell me, and I see people are already starting to fill in the information, why the question is not testable and how you can make the question a testable question. Good job, Lana, on the first one. So Josie, if it's not testable, how can I make it a testable question? You're going to make it testable. So send me a question that will make do plants like water testable. And think about in the video how they told us about the SMART acronym that helps us. Good job, Logan. S. Simmons. Good job, Lana, for the second one. Good job, Samuel. Remember, your goal is to make the question a testable question using the SMART acronym. So specific, I need to have a specific question. Is it something that is measurable? How can I measure that question, which will make it a testable question? Is it achievable? What stuff or time do I have that will make my answer relevant? And remember, you have to have a specific time limit. So any of those things will help your question become testable. Good job, Lana, on the second one. Good job, Francella. All right, so let's look at some of our submissions. All right, so this person says, do plants like water? And they answer the question. Why is the question not testable? It says this is not testable because we don't know if they like water. How can you make this a testable question? It says, will plants like water? So do you guys think that that question is testable? The question that they came up with, the new question that they came up with, is that a testable question? And I'm gonna randomly select someone. Oh, Francella, unmute yourself because she was like the first one in the chat. All right, Francella, why is that question, will plants like water? Why is that? You said that it's not a testable question?
It's not a testable question.
Why not, sweetie?
It's not a testable question because it's not being specific enough.
Right, so it says, will plants like water? Well, what plants are they talking about? What type of water? How much water? So all of those things make a question testable. Remember that SMART acronym. I need to be specific. If I say, well, plants like water, that's an opinion. That's not a factual, because that's just like saying, okay, do you like green? You may say yes, someone else may say no. So that's not a testable question. Let's pick another one. It says this is not a testable question because this is not specific enough to tell us. And then the testable question that they use, do plants need water to survive? Lana, is that a testable question? Lana said no. Lana, unmute yourself.
That is not a testable question because it's not specific enough.
How would we make that specific?
Because it's not like telling us how much or what kind of plant.
Okay, so when it's asking, do plants need water to survive? We could say, does a rose or a peace lily plant need water daily to survive? Something of that nature would make that a testable question. Let's look at one more and then we'll go to the next one. Oh, this person, they're in progress, but we'll see. It says, this is not a testable question. So we all know that the question is not testable. So once we figure out why it's not testable, we need to use that why to make it a testable question. So it says this is not testable because we can't just measure if plants like water. That is true. We can't just measure whether or not a plant likes anything. So they made it more specific, or they tried to make it more specific. They said, do plants grow well in water? Again, we don't know what type of plant, so that would make it more specific and make it testable. So let's go to the second one where it talks about sleep. And I think this is one that a lot of you guys struggled on, especially in the chat. So let's look at this one. Will sleep affect a student? It says this is not testable because it doesn't say what, how sleep, I don't understand that, but doesn't say how sleep affects students. And then they made it testable in their opinion. They said, how will sleep affect students from not paying attention in class? Okay. What do you think, Samuel? Do you think this is a testable question? Their question is, how will sleep affect students from not paying attention in class? Unmute yourself. Do you feel like this is a testable question? How will sleep affect students from not paying attention in class? You need help?
It's just that it says that it's like it's kind of it makes me up. Like it's just not said correctly.
So how would you restate that so that it is a testable question?
Will the amount of sleep a student takes affect them in class?
Okay. So now, when we talk about testable versus non-testable, remember it has to be a specific yes or no question. So if I'm saying how, is how going to give me a yes or no answer? How means that I'm going to have to explain something. And then remember, it requires something that's measurable. How can I measure this? I think if I put, will getting less than 8 hours of sleep affect students from paying attention in class? That's something that's measurable. I'm telling a specific number that I can use in order to make it a testable question. Let's look at another student's response. It says, will sleep affect the student? This is not testable because it is not specific enough. Do students get affected by sleep? That's not measurable either. So remember, when we're talking about testable versus non-testable questions, we're trying to figure out, can we measure something? Is there something that I can measure to figure out whether or not it's true? So when you go into Canvas, there was testable versus non-testable sort. You're going to do that. And remember, as you're doing the sort, you have to make sure that you're using your SMART acronym. Is it specific? Is it going to tell me a yes or no statement? Am I able to measure something? Is it achievable? Do I need stuff in order to do it? Are they using stuff in order to figure it out? And does it have a specific time frame? Okay, so keep that in mind when you go into Canvas to work on the science. The next thing that we're going to do is, if I can pull it up, and I'm actually going to close that out so that you guys aren't working on it now. When you guys do science today, you're going to do the question of the day for Tuesday, and then there's a Kahoot. Okay, so keep that in mind. And the Kahoot password is on Canvas. And I will put it on the screen at the end of the lesson so that you're not trying to do the Kahoot during the lesson. Okay. The next thing we're going to do is math, and math should be really quick. The biggest thing that we want you guys to do, and I'm going to unmute everyone so that we're all, and remember, don't talk over each other. I want you guys to tell me what the difficulty is in doing the exit slip after the lessons. Okay, so if there are 25 of us here, and I'm looking at yesterday's exit slip for math, and 25 people didn't do it. So I'm going to unmute. And if you're finding problems with going onto Canvas after the lesson, tell me what the problem is.
So, every time when I try to do a lesson, it won't let me.
You're doing it on the phone? Are you doing it on the phone, Keandre?
Yeah.
Okay, so you're gonna stay on afterwards, okay? Keandre?
Stay after the lesson today. We'll walk you through it.
Okay.
Okay. Anyone else have problems with doing the exit? It's just like when we're in class, you know, I'm in class, but I set a time limit in class. We have like 5 minutes to do the exit slip. The exact same thing. Anyone else having problems?
I don't know what it's called.
What'd you say? Say it again, Daniel.
I don't know what it's called.
What's what called? You don't know what it's called? We can't, Ms. Rodriguez, you're talking? Oh, okay. You said you don't know what it's called. When you go into Canvas, just like when we were in class, it says exit slip. So when you go to distance learning, like yesterday's exit slip, only 13 people did it. And it says Monday, 413 math exit slip. So all you guys are going to do is after the lesson, you're going to do exactly what we did before. Immediately after the lesson, you go into Canvas. Genesis, can you put yourself on mute? You go immediately into Canvas and you complete the exit slip. And then if it's not working for you, then you're going to stay after the Zoom lesson so that we can walk you through how to get onto Canvas. Because at this point, everyone had an opportunity to get a computer from the school. If you're not able to, were not able last week to get the computer on Class Dojo, there's instructions on how you can get a computer this week. This week, unfortunately, is the last time that they're gonna allow students to come get a computer, but our expectation is that everyone is able to at least go to the school to get a computer. Even if your name's not on the list, if you let us know, we can send an email, talk to Ms. Sarasti or Ms. Hell to try to get you a computer, because we would like it if you're able to do the lessons on Canvas, because it's exactly what we did while we were in school, and it's easier for you guys.
Ms. Bird, I have a question.
Hold on one moment. So is there anyone else that's struggling with getting on to Canvas and completing the exit slip? John?
Francella, was your mom able to call the school?
Yesterday, when my grandma had called.
Francella?
She's gonna do it today.
She can't hold it off much longer, otherwise you won't be able to get one.
I have a question. Do you have to go there with your parents, or can you go with someone else?
You're going to let us know the information. So if you read the information on Class Dojo, just tell your parents to follow those instructions.
My dad doesn't have Class Dojo on
Oh.
his new. He recently got a new phone.
Ms. Rodriguez, you'll send your
I'll send it to him.
Okay. Okay, so I'm assuming everyone else understands the expectation. In our meeting, like Ms. Rodriguez said at the beginning of the lesson, when we had our meeting this morning with Mr. Rasti, literally only 10 people, I think it was 10, right, Ms. Rodriguez? Only 10 people are completing their work successfully. There are 44 people in our classes. So 10 out of 44 is not a good thing. And yesterday for the math exit slip, there were like 32 people on the Zoom lesson and only 13 people completed it. Even if you don't have a computer, if you have the packet, do it on the packet and send me a text message. You can do the same thing for Ms. Rodriguez. The thing is we're trying to make sure that you guys are doing the work. Okay? So keep that in mind. So let's go to the math lesson for today. And remember, after this, you're gonna go right on to Canvas to complete the exit slip for today. So if you're in Canvas, it's a Nearpod again. If you don't have Canvas, it's okay. I'm gonna put it on the screen like we did for science. Ms. Rodriguez, Irene, can you send it to her as well, her mom?
Yep.
My mom went on Class Dojo. They said they was gonna send her some stuff about the computers.
Okay, as long
in
as
a few minutes.
As long as she sent the message to either myself or Ms. Rodriguez. Well, no, your homeroom teacher, Ms. Rodriguez, and she'll sign her up.
Okay.
Okay, honey. All right, so by now everyone should be on Canvas. I have 3 people only. About 2 more minutes. If you're not able to log in, because you didn't finish the exit slip from yesterday, I'm gonna try to unlock it. But usually that's what happens. If you don't finish the day before, it won't allow you to do the next day. So keep that in mind.
Is it math or science?
You tell me by looking at the screen.
It's math, my guy.
And I'm gonna really quick stop it so that I can unlock it for you guys, the ones that did not do it.
Check every month. It's easy to see if you're eligible. Just call the Your Medicare Benefits.
So if you did not complete the exit slip from yesterday, you should be able to see it now. Just refresh your screen. So a lot of people missing that have computers. So make sure if you have a computer in front of you that you are logged in to Canvas. And that you are on the Nearpod. And remember, if you are not able to, you're just gonna send me those responses in the private chat. All right, so let's start. So today, we're talking about comparing two numerical patterns, decreasing in visual representation. So it's similar to what we did yesterday. And if you were able to do the exit slips yesterday, you would see that this is going to be an exact replication of what we did. So they give us a graph with some coordinates on it. And it says, let me make it bigger, sorry. It says, this is Taryn's understanding of the graph. So this is the graph that Taryn is looking at. And it says, is she correct? So she said, I collected the order pairs as 1, 3, 4, 5, 7, 7, and 10, 9. So I'm going to show you just in case you cannot see. This is one of the ordered pairs. Here's another ordered pair, especially for those that do not have access to the computer. Here's another ordered pair. And here's another set of ordered pairs. It says the line is starting at 1, 3, and it is increasing to the right with the rules of the x-axis is at 3 and the y-axis is at 2. So what you're going to have to do is you're going to have to prove the thinking of Taryn. So you're going to tell me whether Taryn is correct or incorrect. And then we're going to make a table from the graph to figure out the rule, starting with the x-coordinate and the y-coordinate. So I'm going to repeat what we have to do. So it's like a twofold lesson. So first we have to look at the graph to see if what Taryn is saying is correct. So she says she collected the ordered pairs as 1, 3. So here's the first ordered pair. 4, 5, 7, 7, and 10, 9. She said the line is starting at 1, 3. And it is increasing to the right, which means it's going this way. So make sure you're looking at the line. With the rules of x-axis at 3 and the y-axis at 2. So we have to figure out, is Taryn correct in her thinking? So the first thing that we're going to do is I want you to look at the graph, and in the private chat, tell me where the graph starts. Not where a coordinate plane starts, but where this specific line on the graph starts. So where does this specific line on this graph start? I'm going to give you about 2 minutes. So my question is, where does this line start? Look at the line, and think about what you know about lines and line segments, which you learned about in 3rd and 4th grade, and tell me, where does this line start? Good job, Sherlyn.
Where was I? Oh, you let Sandy treat me.
Good job, Josie. Good job, Logan F. Good job, Samuel.
What was the question again?
Okay, so I'm gonna have Samuel, I'm sorry, not Samuel, Josie, you were the first one that gave me the correct answer. Can you walk us through, I'm gonna give you control of the screen. Can you walk us through how you solved the problem correctly and then show us as well, okay? Go ahead, Josie. But you have to unmute yourself, sweetie.
Okay. So the little dot, you see the arrow pointing down? That's where it's going. So the top has to, where it starts has to be up there where it first. Right there. And I counted the x-axis where it is, and then I counted to the y-axis where it is too, and I got 10. I got 10-9.
All right, so does everyone understand what Josie is explaining? Thumbs up. Let me see. Okay, so the line has a point on it, right? We all saw the point on the line that Josie was referring to. And with that point is what she was looking at to see where, wrong one, where it was going to stop. Or not stop, start, sorry. So when we think of that, this is gonna show us where our point or our line starts. So this is 10-9. And as you go down, if you see the start of the arrow, which is here, that's gonna show me the ending of my line on my coordinate plane. So now that we know that our line is starting at 10-9, think about the rule that Taryn is using. So I'm gonna give you about 3 minutes and you're gonna send me a message in your private chat to tell me whether or not Taryn is correct in her thinking. So once the timer goes off, that's when I'm gonna come back to ask you guys, is Taryn correct in her thinking? That the rule is the x-axis you're gonna add 3 and the y-axis you're gonna add 2. So look at the coordinate plane to figure out, is Taryn correct? So 3 minutes. Good job, Diana. So remember, you're telling me whether or not she's correct, and tell me how you know this. If she's not correct, what is the correct rule? If she is correct, prove it to me. So it says to prove you're thinking that Taryn is correct or incorrect, you should probably make a table for this graph. So Josie already showed us that it starts at 10:9. So the first point is here. And we know that it's going down to the left. If this is the second point, what is that coordinate? If this is the third point, what is that coordinate? And if this is the fourth point, what is this coordinate? Good job, Sherlyn. Good job, Josie. Sorry, I went ahead, sorry. Yes, Keandre. So remember, you're telling me what the rule is for this specific graph. Okay, John Carlos, so now tell me what the rule is. So you're correct in your thinking, but tell me what the rule is that Taryn's graph is displaying. Okay, so my question is, I know, according to Josie, that my line is starting at 10:9. We know that because remember, prior to us doing this type of lesson, we know that each of these lines represent a number, and Ms. Bird's handwriting is horrible, but you guys get the idea. So we know that it's 10 over here. That's what Josie told us. This is 10 on the x-axis. And then if we go across, we know that this is 9 along the y-axis. That's our first point. So then when we go to our second point, which is, oops, that's so raggedy. Good job, Sherlyn. Then we go to the next point. So looking at these ordered pairs, And we know that, like Josie said, if I'm starting here, I'm decreasing. And I know that I'm decreasing because when I looked at my arrow, remember arrows have points like this? This is telling me the direction in which my arrow is going. So if I keep that in mind, here my arrow is facing this way. Remember what Josie said? So that means this is not the start of the arrow. The arrow is going, I'm sorry, not the arrow, the line. The line is going to start here and it's going to be going this way, which is what our line is doing on our ordered coordinate plane. So now if I'm starting here and I'm going down, what rule is Terran's graph displaying? And hopefully that makes sense. All right, so now Diana, you're going to tell us what's going on Terran's graph and tell us the rule. So Josie already told us where we're starting. And you tell me what's going on her graph, please.
What's going on her graph is that since the line's pointing down, instead of actually adding, you're gonna subtract. So like Jonesy said, we start on 10, 9, and then the closest to 7, 7, which would be if you subtract 10 from 3, you would get 7, and if you subtract 9 from 2, you get 7. Then you go ahead and look at 7, then look at 4, 5, and then you go ahead and do the same thing. Subtract 3 from 7 and 2 from 7, and you get 4, 5. And then all you have to do is just subtract 3 from 4 and 2 from 5, and you'll get 1, 3.
So what's on x-axis?
Drop the mic.
Yeah. So in the x-axis, we're actually subtracting 3.
And what's going on the y-axis?
And the y-axis, we're actually subtracting 2.
Good job, sweetie.
That's on period.
Does everyone understand what Diana explained? Thumbs up so that I can see. Okay, good. Good, 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 good. Leah, you look confused. Everyone else has a thumbs up. Good job. I don't know who iPhone is, but you understand, so there's that. Okay, Leah, thank you, honey. All right, Dulce Floor, everyone understands. All right, so you're gonna do the exact same thing with your exit slip. You're gonna look at how the arrow is facing. Remember, the arrow starts where the tip is not, if that even makes sense. So this part is pointing me the direction in which my arrow is going. Logan, that's so weird. That's pointing me the direction in which my arrow is going. So therefore, I'm not starting here. I'm starting back here. So keep that in mind as you guys look at your exit slip, okay? So the exit slip, which is on Canvas again, it says, given the list of coordinates, create ordered pairs, determine the pattern, and explain what is happening in the chart. So you're gonna look at the x-axis, you're gonna look at the y-axis, and then you're gonna create a list of ordered pairs, just what Diana explained to us. And then we're gonna talk about the rule for the x-axis and where the x-axis starts, and then the rule for the y-axis and where the y-axis starts. Any questions about the exit slip? Okay. So your
Mayor.
goal today, this is our goal today, is to actually finish your exit slip. So if we just did the lesson and it's fresh in your mind, my whole thought process is that you guys should go onto Canvas, even if you don't have Canvas and you have the packet, go into the packet, complete it, send me a text message with the answer. You have a question, Diana, about the math? About math?
Yeah. So I've been working on it, and when I'm looking at y-axis, I can't process it.
Is this about the exit slip?
Yes.
Okay,
I
wait
can't
till
process
afterwards.
it.
Wait till afterwards.
Okay.
All right, we're gonna do attendance. Do not hang up.
After attendance, we need Kevin, Rochelle, Keandre. I don't think Denzel is here, but we need him. Stephanie, if you're here, Dulce Flor, Omar, and Jair. And before you leave, John and Daniel, I can see that you've gone in to do some work, but you need to go back to the week of 3:30 and start there. You haven't done anything for the week of 3:30. Make sure you're going back. Okay, so when you go into Canvas, scroll all the way down, find reading and math for a week of 3:30 and make sure you do those assignments. Kevin, Rochelle, Keandre, Stephanie, Dulce Flor, Omar, and Jair, please do not leave. And I have Francella, Logan, Jackendall, Sherlyn, Amari, Leah, Dulce Flor, Anaí, Akisha, Daniel, Logan, Gabi, Sebastian, Samuel, Rochelle, Anima, Wilfred, Kevin, Amelia, Lana, Keandre, Irene, Genesis, Orlin, Josie, Giancarlo, Anaya, Diana. If I missed you, unmute yourself and tell me your name. Okay, make sure you go now and get the exit slip done before you leave on your discussions for reading. You need to answer the question on the discussion, answer the question using the race strategy, and then you have to reply to 2 other posts specific, not just I agree. What is it that you agree with? Okay, make sure that you're elaborating on there. All right, if you don't need us, see you tomorrow.
See you tomorrow, guys.
Bye. See ya.
Bye.
Bye.
Can I ask about the exit slip now?
Hold on, honey.
Bye.
Bye.
Miss Bird.
Bye.
Bye.
If I didn't call you and you don't have any questions, you can leave. If I called you, you need to stay.
Miss Bird.
Yes, honey.
Miss Rodriguez.
Yeah.
The computer thing, is it today
No.
or is it like tomorrow?
Have your dad go on to Class Dojo. It explains it.
I
Okay.
sent a message.
Huh?
I sent a text message to the phone that I have listed, Josie.
On Class Dojo, it explains the exit slip?
We're talking to Josie. Hold on, Diana.
Okay.
Diana, what's your question?
I was trying to solve the exit slip, but I can't even find a rule for y-axis. I've tried drawing a chart and all that stuff.
Freezing. My computer keeps freezing.
Ms. Bird, that's a you question.
Oh, I'm texting a parent. I'm sorry. Hold on. Oh, let me hit stop on the recording first.